Okay everyone, welcome. This is topic 7, page 20 of the workbook and question 2. Okay, so what we need to do, draw the FBD for the object, find the x and y components of the angled applied forces, calculate the unknown forces acting on the object, which are the normal force and the kinetic friction, and then determine the acceleration of the object. Perfect. So what I'm going to do right away is I'm going to make my reference frame over here. Since my force is going northeast, I'm going to make north and east positive, then I'm going to make south and west negative. And now in this corner here, I'm going to draw the FBD. Okay. So here's the box, all at the table. It's got its FG, its Fn, and I could angle the force, but what I'm going to do instead is add another arrow up, and this is going to be FAY and FAX, and then going in the opposite direction, it's going to be FK. Perfect. All right. So let's just write a few things down. We have mass equals 5.0 kilograms, and our kinetic friction value coefficient is 0.15, just to remember. All right, so let's start off by breaking down, we can check that off, breaking down the FA into its x and y components. So I'll draw that vector here, 44 newtons, and an angle of 45 degrees. So first, let us find this one here, the y component. All right, so we're going to use sine, because sine is equal to opposite over hypotenuse. And we were trying to find the opposite here. And we'll do some rearranging. We're going to have sine of, I'll sub things in and then rearrange, sine of 45 degrees equals opposite over 44 newtons. So then I'll have 44 newtons times sine of 45 degrees equals opposite angle, or our y for our applied force. So I'm going to punch that into my calculator. Perfect. We get a value of 31.1126 newtons, or to 7 actually, but I'm going to round that just to keep track of it to 31.0, I believe. Yep, 31, just 31 newtons, because our 44 is just two significant figures. Okay, so that was y. Now let's do x here. Same thing, this time we're going to use cos. Oh, my bad. It should be adjacent over hypotenuse. And I'm going to skip the rearranging, and that's going to give us 44 cos 45 degrees. It's the same rearranging as the other side, equals adjacent. And just throw that into your calculator one more time. And we get the same answer just because it's an isosceles triangle, that's okay. 31.1126, or I guess, yeah, just rounded as that. We'll go 27, or 31 newtons. Perfect. So let's check that off here. All right. Now we want to find the unknown forces. So let's do our normal force first. So Fn. Right, so for a normal force, it's actually going to be Fn equals our m times force due to gravity, so mass times force, acceleration due to gravity, I should say. And then it's going to be minus our Fay. And that's going to give us our normal force. So basically what I'm doing here is since the acceleration due to gravity is negative, to get that positive normal force, we inverse it. Since our our applied force, our FAY, is positive, we inverted it as well. It's kind of like we're pushing up from under the table, which actually kind of relieves the force on the table, which makes less normal force rather than more normal force. So let's just do that here. Fn equals 5.0 kilograms times 9.81 meters per second squared minus 31.1127 newtons. Perfect. And now let's calculate that. So the first part's going to give you 49.05 newtons, and then that will be minus 31.1127 newtons. I'm just going to put that in my calculator. And you should get about 17.9373, or we're going to round it to 2 significant digits because of the 5 kilograms still, 18 newtons up. Perfect. Now we need to find the kinetic friction force. So let's go down over here. We're going to write that. Force of friction equals mu Fn. So this is going to be super easy. That's going to be equal to 0.15. I'll zoom out. You can see that was our mu value from before, times our 18 or 17 point, what was it? 9373 newtons. And let's punch that into the calculator. And that's going to give us 2.6906 newtons of force. And then I'm going to round that to 2.7 newtons because we still need 2 significant digits because that number came from over here where we had 5 involved, just 5.0, which makes it 2. Perfect. So let's check that step off. And now determine the acceleration of the object. Hint, you need to find the F-net first. Perfect. So the object is going to be accelerating in the x direction. Okay, so to find the acceleration, we're going to be doing F net x is equal to FA plus FK. Perfect. And that's going to give us, what was our value there? 31.1127 newtons. And this is going to be minus because it's going in the opposite direction as we sort of highlighted over here earlier. Minus 2.7, or I should actually not use the rounded value, 2.6906 newtons. That's going to give us, let me pull out my calculator. .4221 newtons. And this is all part of finding the acceleration. So A is equal to F, or A system, is equal to F net system, and this is X, divided by our mass. So that's going to be 28.4221 newtons, divided by 5.0 kilograms. That's going to give us 5.68442 meters per second. That got a little big. I'm going to rewrite that. 5.68442 meters per second squared, or 5.7 meters per second squared to keep it to significant digits. Perfect. I believe that's everything. There, we found the acceleration.